Good afternoon, everyone. Welcome to this discussion session. This week is a review week, so we will review some problems related to probabilities and counting. Let's get started with the first one. I will give you 2 minutes to think about it, and please feel free to type your answers in the chat, and we will discuss it after 2 minutes. We can use some general notations. That is, we can let S to be the sample space. And let E be the events that more heads than tails appear. So in order to calculate the probability of E, we need to know what is NS and what is NE. So if you have some idea about what is SN, NS and what is NE, please type it in the chat window. Okay, thanks, Peter. That the NS is equal to 2 to the power of 4 because we needed to throw the coin for 3 times, and for each one, it has 2 choices. It could be either head or the tail, so it is 2 times 2 times 2 times 2. So it is equal to 2 times the power of 4, and it is equal to 16. And then what is NE? Yes, here is another answer, that is NE is 4 choose 4 plus 4 choose 3. That is absolutely correct. So what this means? This means from the if we use H to represent head and use T to represent tail, then if head is more than tail, that means we can have 4 head, 0 tail, or 3 edge, 1 tail. And it can be only these 2 cases. So in the first one, we have 4 coins, and all of them are H, so it is 4 choose 4. And for the second one is that we should choose 3 positions to put heads on, such as this one. So it is 4 choose 3. So H is equal to 1, so NE is equal to 1 plus 4. It is equal to 5. Then we use these two numbers to substitute it in this function. So PRE is equal to ME over NS. It is equal to 5 over 16. Any questions so far? Okay, let's go to the next question. Please use 3 minutes to think about it, and please feel free to type your answers in the chat window. Problem 5C. I need to check what is 5C. Okay, I think the 5C is a question similar with this one, so maybe you can try this question first. Oh, there is another question, the next question that is more familiar, more similar with the 5C in the homework. Maybe you can read and do that exercise in the discussion first, and then you think about the 5C in the homework. Okay, this question is about expected value question. So we need to identify what is x and then to calculate what is expect value of x. So can anyone tell me what is x? So in this question, x can be the length of the game. Serious. So can anyone tell me what is x?
Three, 4, and 5?
Yes, thanks for your answer. Actually, yes, it is 3, 4, or 5. And Parker said it's 1, 2, 3, 4, 5. But if it is just 1 or 2, it's not allowed, but because you cannot decide who wins the game. Because if some of them win 3 games, then he wins the overall game. So the shortest length of the best of 5 series should be 3. And then from our functions, we know EX is equal to 3 times the probability of X equal to 3. and plus 4 times the probability of x equal to 4 plus 5 times the probability of x equal to 5. So then we need to decide what is the probability of x is equal to 3. So we have two cases, is that either Bison win or Mustangs win. So if Bisons win, that means if Bisons win in 3 games, that means it wins 3 times. So it should be 3 over 5 to the power of 3. This means in this game, it is B, B, B. It is B, B, B in this case. And also it could be 2 to the power of 5 over 2 over 5 to the power of 3. This means M, M, N, which means Mustangs win 3 times. Any question about this statement? And this is equal to and then we need to calculate the probability when x equal to 4. That means we need to play 4 games to decide who wins the game. So we still have 2 cases. One is Bisons win, and another is Mustangs win. So what's the probability if Bisons wins in 4 games? And still, we need to remember that if we want Bisons to win in exactly 4 games, which means for 4 games, Bisons should win the last one, and then you should choose 2 positions that Bison is win. Yes. So thanks for Elizabeth's answer. So we need to choose 3 or choose 2 from 3 to put B on, and then this is and then to calculate the probability, and then to multiply the probability of Bison's win, and then because this one is Mustangs win, so we still need 2 times 2 over 5. And in this case means Bison's win. Still, we need to calculate that Mustangs win the last step. So we still need to choose 2 places to put M on, and then it should be 3 choose 2 times 2 over 5 to the power of 3 times 3 over 5. This item is because we still need to put a B in this case. Any questions so far? And similarly, we can calculate the probability of when x is equal to 5. And still, if license wins the game, we should choose 2 from 4. And the other 2 is m. Plus the case is 1 Boston's win. So it is equal to so we are done for the probability calculations for each case. And finally, we needed to use these values in these functions. And it is equal to it is equal to 4.0656. So we are done with this problem. Any question about this problem? So the key idea is, firstly, you need to decide what is x. And then you need to calculate the probability of each case. And then you can add them together. This is the main idea to solve the problems related to expected value. Okay, let's go to the next question. Please use 3 minutes to think about it, and then we will work on it together. Still, I will give you some general notification first, and then you can tell me what is the value of this notation. So let S be the sample space, and let E1 be the events that at least one dial shows 5. And let E2 to be the event, the die sum to be 8. So we need to know what is NS, what is NE1, and what is NE2. You can type your solutions in the chat window, and we will discuss it together. Yes, NS is equal to 36 because 3 times 3. Okay, there is an answer from Cameron that is NE1 is equal to 11. It is correct. That is, can be the total number that is 36 minus that there is no 5. If there is no 5, that means we can choose the first items from 5 integer, that is 1, 2, 3, 4, and 6. And still we can choose we can choose the same 5 integers from these 5 numbers. So it is 5 times 5. So it is equal to 11. So we have 11. So the value of NE1 is 11. Then what is NE2? Okay, thanks for Peter's answer. It's 5. It is also correct because if we want the 2 dice to sum to be 8, it can be 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. So we have NS is equal to 36. NE is equal to 11, and NE2 is equal to 5. And then we need to calculate the probability of E1 or E2. Okay. The probability of E1 or E2, which is equal to the probability of E1 plus the probability of E2 minus the probability of E1 and E2. Okay. So, which is equal to NE E1 on NS plus NE2 over NS minus NE1 and E2 on NS. Yes. So we still need to decide what is NE1 and E2. It is equal to 2 because these 2 items has 5, and it is the same. It is also can be shown in E1. So E1 and E2 is equal to 2. So then we need to use all the values in these functions. It is equal to plus 5 minus 2 over 66. And it is equal to 14 over 36. It's equal to 7 over 18. And we are done with this question. Any questions so far? Great. Let's go to the next one. So this is still a question about the expected value. Please use 3 minutes to think about it, and then we will work on it together. And so we still need to decide what is X. And the X is the amount of money. And please read it and tell me what is X in the chat window after you finish it. Yes, we will need to use NS, that is 6 to the power of 3 in this problem, but we needed to decide what is X first. Yes, thanks for Parker's answer. So it can be 10, 25, or 45. So EX is equal to time times the probability that the player has 1x or 1/6, and plus 25 times the probability that the player has 2/6. Plus 45 times the probability that the player has 3/6. And then we need to decide what's the probability of the player has 1/6. So we have already known the NS is equal to 6 to the power of 3, and the number of the events that the player has 1/6 is what? Yeah. Yes, the order of the dice matter. That is because, for example, you have three dice. You have 6 in the first one, and then you have, no matter what, with 3, 1. This is different that you have a 6 in the second throw. So if we test one dice, the amount of this event is we should choose 1 to put the 6 on. And then for the rest of them, it has 5 choices for each one. So it is 5 times 5. Okay, so we needed to decide the total number of the events that we have a 6 in this player. So, for example, these two are different. Do you agree? And still, this is different. Do we need to subtract the events with 2? Sorry, I don't know what's your mean, Peter. Do we need to subtract the events with 2 and 3 dice from the first one? I don't know what it means, but we can think about it this way. So you have you play a game and you need to calculate the number of ways that there is exactly 1/6 in a 3 game. Oh, okay. This is the question. This is the problem with the description of the problem. That means, which means the first die is that you play with it, and then you throw. If you throw a number with 4, and then throw a number with 6, and I will say I will get the 6 I will get the first 6 from this game. So if I get another 6 here, I will say I get the second 6 in the third row. Yeah, that means this 6 can be anywhere. And when you get a 6, you can say this 6 is your first 6. And then if you throw again and you get another 6, you say this is the second 6 I'll get from the game. It not means that you must have the 6 in the first throw. Any other question? Okay, then we need to calculate the probability that we have 2 6 in this game. So we need to choose 2 from the 3 position, and with the last one, we have 5 choice. So you can put the 6 anywhere. For example, in here is this one, and maybe this one is another numbers, and you will say I get the first 6 my first try and get my second sex in the third try. So this one is still allowed, and this is the probability of we get 2 6. And 3 choose 2 is where we put the 6 in, and the final one for this items we have 5 choices from 1, 2, 3, 4, 5. So we need to times 5 in here. And then finally, we need to calculate the probability of we have 3 6. And it is, we only have one way to do that. So it is 3 to the powers 1 divided by 6 to the power 3. And then we needed to use these values in our function, and we get So let's talk about the part B. How much can the casino expect to make if 10,000 of these games are played each day? So we have already know that for each game, a player paid $10 to the casino. So casino will get $100,000 before game start. And then, because for each game, a player is expected to have $1.42 back from the casino. So we needed to have yeah, thank for Peter's answer. That is absolutely correct. So it is then we need to use 100,000 minus 5 points times 10,000. It is equal to 45,800. Any questions so far? Okay. Let's go to this question. And we only have 7 minutes left, so I will give you 3 minutes to think about it, and then we will work on it together. Still, we need to decide what is X, and let X be the number of seniors on the committee. So what do you think X could be? Actually, 0, 1, 2, 3, and the 1, 2, 3 are all right. I don't write 0. It is because if we calculate the expected value of X, then 0 times the probability of X equal to 0 will always be 0. So for most cases, we can cancel these items. So whether or not you write down 0 is all correct. So what is the probability of X equal to 1? You can still write down what is NS and what is NE1. And E1 means there's 1 seniors on the committee. Okay, thanks for Parker's comment. But can you tell me what is NS? The NS means the number of ways to create the committee, 3-member committee. Yes, correct. So NS equal to 15 choose 3 because we can choose 3 members from the 20 seniors plus 30 juniors. So it is 15 choose 3. Then what is NE? NE means the community has exactly 1 senior. Yeah, so we can choose one from 20 seniors and then the other two should be 30 choose 2. So PR is equal to 20 choose 1 times 30 choose 2 over 15 choose 3. So it's a little complicated. And then we need to decide what is the probability of x equal to 2. So I think NS is the same, but now we need to decide what is NE2. E2 means that there are 2 seniors on the committee. We don't need to plug it in to a calculator, so you can just write down what is PR x equal to 1 and what is the probability of x equal to 2. You don't need the final answer of it in the quiz. Yeah, so we have the NE2 is equal to 20 choose 2 times 30 choose 1. And for the probability of x equal to 3, similarly, I think it's 20 choose 3 or 40 choose 3. So in the quiz, you only need to write EX is equal to 1 times So in the quiz, you only need to write here. Here is enough, but I will say the final answer is 1.2. Okay, actually, we still have another 2 problems, but I've already run out of time. So I will write down the answers for the last 2 questions, and you can see it from Canvas. So are we allowed to use calculators on quiz or final? No, you are not allowed to use the calculators. And if there are some calculations, and you should do it by hand because it will not be difficult. Any other question? If no, okay. Thanks for coming to these discussion sections, and you can find the other answers on Canvas. And good luck.